if we can switch from polar coordinates to rectangular coordinates, then surely we should be able to switch from rectangular coordinates to polar coordinates. So let's see how that would work out. Based on our experience from going from polar to rectangular, you can bet that we should start out with a most important diagram involving this point. So this point is x comma y in rectangular coordinates, and we're going to imagine that we know x and y and we want to find r and theta. So let's draw a diagram that shows us all of these quantities. So x is the horizontal position, y is the vertical position, r is the distance from the origin, although r could be negative, right, depending on how you set up your angle, and theta is this angle here. Okay, so we want to find polar coordinates r comma theta for this point. So if you know x and y, imagine trying to find r. Well, we have this right triangle here, and anytime you know two sides in a right triangle, you can find the third side using the Pythagorean theorem. So r squared is x squared plus y squared. And actually, we can't go any further. I mean, we could take a square root to say that r is plus or minus the square root of x squared plus y squared, but remember, negative r values are perfectly fine. So we actually need to acknowledge both or allow both possibilities here. So to keep us from forgetting the fact that we have two possibilities, I'll usually leave it like this. So r squared is x squared plus y squared. And then we need to find theta somehow. Well, to get an angle from this situation, we need to use some sort of trig function of theta to relate the sides to the angle. And since we're imagining we know y and x, it seems like we should use both of those rather than getting r into the mix. And using for the opposite side and the adjacent side, that sounds like a job for tangent. So tangent of theta equals y over x. The only time this wouldn't work is if x is 0. But if x is 0, that means you're on the y-axis. And if you were on the y-axis, presumably you would notice. So if you don't notice and you try to take inverse tangent, you'll get an error, and then you will notice that you're on the y-axis. So one thing we need to be careful about here is, so it's tempting to say that, well, if tangent of theta is y over x, that means theta is inverse tangent of y over x. But that is not always true. It depends on what quadrant you're in. And we'll see examples. So I'm going to leave this expression relating theta to x and y like this, so that hopefully we prevent ourselves from thinking that we can just take arctangent without thinking about it. Okay, so we have these two equations that let us switch from rectangular coordinates to polar coordinates. So let's see if we can use them. Okay, so let's look at example A here. So this is in rectangular coordinates. So 3 is our x coordinate, negative 4 is our y coordinate. This is in rectangular coordinates. So r squared is x squared plus y squared. So that's 3 squared plus negative 4 squared. So 9 plus 16, that's 25. And so the r values that we get are plus or minus 5. Now for theta, we know that tangent of theta is, let's see, y over x, so negative 4 over 3. And right, theta can be any solution to this equation. As we saw when we were, as we saw in a previous video, there are lots of different angles that can show up in the coordinates in the polar coordinates for a point, and they're all solutions to this equation. So we need to actually write down all solutions to this equation, not just one or two solutions to this equation. And if you solve this equation for theta, you get, well, your first solution you do get by just taking inverse tangent. So inverse tangent of 4 over 3 plus, well, we can add any period for tangent and get another solution to the equation. So plus pi k. And again, k is any integer here. Okay, now we have two possibilities for r and two possibilities for theta. It's tempting to say, we're done. It's plus or minus 5, comma, inverse tangent of negative 4/3 plus pi k, and say these are the polar coordinates. But actually, this is not good enough, because writing this implies that either of these r values go with any of these angles, but that is not true. To see why that's not true, let's plot this point. We haven't actually ever plotted this point. So 3, comma, minus 4. So 1, 2, 3 in the x direction, 1, 2, 3, 4, negative 4 in the y direction. So there's our point, 3, comma, minus 4 in rectangular coordinates. So when we combine r values and theta values, we need to be sure to choose combinations that put us in this fourth quadrant. If we choose combinations of r and theta poorly, we'll end up in a different quadrant. So first, let's see what angles work with the r value plus 5. For our r value to be plus 5, that means the angle that we choose needs to be pointing into the fourth quadrant. Okay, one angle that points into the fourth quadrant is arctangent of negative 4/3. Right? The range of inverse tangent is from minus pi over 2 to plus pi over 2. So this angle is between minus pi over 2 and pi over 2. And so since we have a minus sign here, it has to point into the fourth quadrant. Okay, so that's one angle that would work. If we add pi to that, well, that would point into the second quadrant, not the fourth quadrant. So we can't just add pi to this angle. But if we add 2 pi, now we're in the fourth quadrant again. So we can add 2 pi. You can see that we could add 2 pi again and again and again. So we could add 2 pi k. So all of these points are valid polar coordinates for the point 3, comma, minus 4 in rectangular coordinates. And that was just with the r value plus 5. So now let's see about the r value negative 5. So again, we're going to start with inverse tangent of minus 4/3, which again is down in the fourth quadrant here. But if we're going to use a negative r value, that means the negative r direction should be pointing here. But for this angle, since this angle points into the fourth quadrant, that would mean the positive r direction is pointing into the fourth quadrant. But we want the negative direction to be pointing into the fourth quadrant. So that means we need to swing this angle around up to there so that the positive direction points that way and the negative direction points into the fourth quadrant. In other words, we need to add pi to this. So we need to add pi. Of course, now that we have one angle that works, if we add any number of full terms, we get other angles that work, so plus pi plus 2 pi k, as usual. Okay, and so there are two collections of polar coordinates, one with a positive r value, and one with a negative r value. Okay, you can see going from Cartesian coordinates to polar coordinates is substantially more complicated than going in the other direction. Okay, our second example was minus 1, comma, minus 5. So let's do that one. and this is in polar coordinates. Oh, before we move on, let me just say that if you wanted to get a decimal approximation for what arctangent gives you here, that would probably be fine in most contexts. I just don't have a calculator right next to me. Okay, so let's find rectangular coordinates for this point. Remember, the equations we're working with are r squared equals x squared plus y squared, and tangent theta is y over x. Okay, so let's find r first. So r squared is minus 1 squared plus minus 5 squared, so that's 1 plus 25, and that is 26. And so r is plus or minus the square root of 26. All right, now for our theta value, tangent of theta is y over x, so that's negative 5 over negative 1, and that's 5. So theta is inverse tangent of 5 plus any multiple of pi. Although, as we saw in the last example, the even multiples of pi and the odd multiples of pi go with different r values, so we'll have to be careful here. Okay, to sort out which angle goes with which r value, pay attention to what quadrant you're in. So this point, I've written polar coordinates here, but this was in rectangular coordinates. This point, minus 1 comma minus 5, is going to be something like this in the third quadrant. So if we choose the positive r value like this, square root 26, our positive value for r. Well, to figure out, we're going to start with inverse tangent of 5. And then the question is, do we need to add pi to this before we add 2 pi k? To figure that out, we need to know what quadrant is inverse tangent of 5 in. Now remember, inverse tangent gives you an angle from minus pi over 2 to plus pi over 2. That's the range of inverse tangent. So the angle that inverse tangent gives us must have the same slope as this blue line, but it has to be in the right half plane. So inverse tangent gives us this angle. So this is inverse tangent of 5. You can see that the angle inverse tangent of 5 is not pointing in the direction we want. So we need to add pi here. And that will give us an angle that points towards the point instead of away from it. Okay, and of course, now that we have figured out one angle that works, we can add 2 pi k, where k is any integer. All right, and now for the negative r value, again, we'll start with inverse tangent of 5. We had to add pi to the last one, so for this one, probably we don't need to add pi, but let's just make sure. So we have a picture of inverse tangent of 5 here. So if we, inverse tangent of 5 makes our angle point up and to the right, and that means negative r values would go down and to the left, and that's going to send us towards our point. So for negative r values, we do not add pi here. And this is because our point is in the third quadrant. So we don't add pi, but of course we do add 2 pi k, because we could send that angle all the way around again. All right, and that is going from rectangular coordinates to polar coordinates. As long as you're careful about the quadrant that you want to end up with, in, it's not too bad sorting out which angles go with which r value. But if you aren't paying attention to the quadrant that you start out in, things are sure to go wrong. So pay attention to the quadrant you're in.